Good afternoon, everyone. In this video, we are going to work out one of the atomic structure question extracted from 2012 Science Paper 3. This is the question that we are going to work out together. You can run through or read through. Let's begin now. The question reads, an element has an isotope with a nuclear number of 7. Each neutral atom of this isotope has 3 electrons and a nucleus containing 2 different types of particles. A1. Give the name of these particles and the number of each particle present in each nucleus. So to answer this question, you need to understand what an isotope is. So we define an isotope as the atom of the same element having the same proton number but different number of neutrons. So that is a definition of isotope. They are made of the same atom or element having the same number of protons but different number of neutrons. So now, how do we answer now this question? So now you need to understand the structure of an atom first. An atom has got 2 important parts that you need to know. One, it has a nucleus. The other part, it has shells. So the 2 important parts of an atom is the nucleus part and also the shells. The nucleus part, that is an inner part of an atom. And then the shells, that is the outer part of an atom. Now, you also need to know what is found inside the nucleus. So inside the nucleus, we have what we call the protons. Protons are found in the nucleus of an atom. We can also find the neutrons. Neutrons are also found inside the nucleus of an atom. So it will show this, it will look like that. So that is the nucleus of an atom, and inside there, those are the particles of an atom. One of them, the ones in red, those are protons, and the ones in blue, those are what we are calling the neutrons. Then, what do we find on shells now? On shells, there are electrons that can be found there on shells. So now, how do we demonstrate them graphically there? So we are going to show them like that. So we have the inside part there, that is the nucleus containing the protons and the neutrons. Then the outer part, those rings like circles, where there are even those black, those are electrons. So those black spots, those are electrons. So those are what we are calling shells. Now to answer our first question, it is very easy now because they want to know, they are saying each neutral atom of this isotope has 3 electrons and a nucleus containing 2 different types of particles. Now, in the nucleus, there are 2 different types of particles. What are those particles? Are the ones listed here, because under nucleus we are saying we have protons and also neutrons. So you just answer there and say one of them is the proton there, and the other one now will be the neutron. So that is the answer. So we've just answered one part of it, which is saying give the name of these particles. So the names are protons and also neutrons. Now, to answer the second question, which is saying, and the number of each particle present in each. So now what they want here is to give how many protons are in this nucleus and how many neutrons are also in this nucleus. That is what they want. So how do we tell that there are so much protons and neutrons in this particular atom? So now, one key element that is going to guide you here is this same one here. At each neutral atom of this isotope has 3 electrons. That is the statement that is going to help you to determine the number of protons. So now, how are the electrons going to help us? Remember that concept in lesson 1 that we did under atomic structure. We said that the number of electrons equals the number of protons. So here is the concept that we are going to use. The atomic number will equal the number of protons, will also equal the number of electrons. So if the electrons are 3, meaning even the proton number will be 3. Even the atomic number will be 3. Therefore, the number of protons in this particular atom will be 3 there. You write like that. You are done. Now, coming to the number of neutrons, though it is written there, but we need to explain how we can find it. Now, remember that concept we said that mass number is equal to, now before I go there, when you read the question here, it is saying an element has an isotope with a nucleon number of 7. So it is wise of you to know what a nucleon number is. So now let me explain further under the nucleon number. So for the nucleon number, you should understand that these are just scientific terms that they use. Otherwise, nucleon number, it is as good as the atomic mass. If you still don't get atomic mass, nucleon number is just as good as the mass number. So meaning the mass number of this particular atom, it is 7. So now to find the neutron number, you use this concept here where we say mass number is equal to number of protons plus the number of neutrons. Meaning when you add the protons and the neutrons, you should get a mass number. So we know the mass number is 7. And the number of protons we've already found, which is 3. You just substitute in your equation there, like that. So meaning we have 7 is equal to 3 plus the new number of neutrons, which we don't know. From there, you collect your like terms, as usual, like that. Then finally now, you will subtract 7 minus 3, it will give us 4. Hence, the 4 there. So that is how you should complete this table. Coming to A2, compare the masses and the electrical charges of these particles. So there are only 2 particles that we have answered here, the protons and the neutrons. So they want us now to compare their masses, the mass of a proton and a neutron. Again, at the same time, we are asked to compare the charge of a proton and a neutron. So we'll start comparing their masses. We'll start comparing their masses. So a mass of a proton and a mass of a neutron, they are equal. It is 1 AMU. That is, they both have the same mass of 1 AMU. The letters AMU, they stand for atomic mass unit. So meaning each proton and each neutron, they have a mass unit of 1 atomic mass unit. Coming to their charges, you know, when you define protons, we define them as positively charged particles of an atom. So the proton is a positively charged particle, but the neutron, they do not possess any charge, meaning they have no charge. So there is the comparison between their charges. So proton is negatively charged, while neutron has no charge. To make reference, you can make reference using this table here. I'm sure you are able to recall now perfectly when we did atomic structure lesson. So this is, you can refer to this table here. Coming to B, what is the difference in the nuclei of this isotope and its isotope whose nucleon number is 6? So now, when you read carefully and understand this question, it is asking us to identify the difference, or to write the difference in the nucleus. So remember, in the nucleus, there are only two atoms, particles there, the proton and also the neutron. Nothing else. There are only two particles there. So now we have to get to know the difference of these isotopes. So we have two isotopes here. One, the first one that we are from working out, which has got a mass number of 7. This one here, a mass number of 7, and also the protons, or the atomic number which we did find, were 3. Now the other one, now they are saying it has the mass number of 6. Remember the definition of isotope: having the same number of protons. So meaning this one, even when it has a mass number of 6, the protons will still be the same. The atomic number will still be 3, meaning it will look like that. Because these are isotope, they are made up of the same element. No wonder it is XX. Having the same protons, no wonder it is 3. But different their mass numbers, meaning different their number of neutrons. So we have 7 here, mass number, and the other one, it has got 6. So now they want to know the difference now in the nucleus. So what do we have in the nucleus? We have the protons. That is what we have in the nucleus. We also have the neutrons. These are the particles that are in the nucleus. Now let's compare now. Let's get to know the difference in their protons. So when you look at the protons, the first isotope there, it has got 3 protons. Coming to the second one, it has got also 3 protons, meaning the difference there is there. So meaning this one, it cannot help us anymore. So we'll go to the neutrons. We'll check out the other one, which is the neutrons. So you check how many neutrons are there. We already found from the first question. So we got 4, because we subtract 7 minus 3, which is 4 there. Remember what we did there. Now coming to this one, of course we did not work it out, but we can still do the same, where we'll subtract the 6 minus 3, meaning mass number minus protons to get the number of neutrons. Or if you've forgotten, we can still do it together as follows. We have mass number is equal to protons plus neutrons, like that. Then the mass number there, we have 6. The protons, 3. The n still remains because we're trying to find n. Then you collect the like terms like that, and then you subtract, definitely you have a 3. Meaning in this other isotope, the one which is, let's say, isotope 6, the one with a mass number of 6, it will have the number of neutrons as 3. So now, what's the difference now? The difference now for this particular question lies in its number of neutrons, because that is where we are able to see the difference. So meaning, to do that, we are going to know the difference. The difference is just to subtract. So we are going to subtract 4 minus 3 to get the difference. So the difference there is 1. So to explain this, or to answer this one now, academically, this is what we are going to do, to say the difference in number, the difference lies in the number of neutrons, and it is what? 1. Thank you so much for watching this video. Stay tuned.